Hello and good day. We're back with Geometry Blue. More about polygons. In CO8, we classified them by the number of sides. Today we're going to talk about different terms like regular, different polygons, regular, convex, and concave, including correct labeling. Anyone heard either of those three terms used to describe polygons before? And if you have, go one step further and give me the definition of a regular, convex, or concave polygon. You've heard it. Well, that's a start. Gabby?
I don't know for sure, but is it regular where all of the sides are the same?
Yes, all sides and all angles are congruent. Regular polygon is a polygon with congruent sides and angles. A polygon with congruent sides and angles. An example, of course, would be a square. Okay, 4 congruent sides and all angles are 90 degrees. An equilateral triangle, all congruent sides. Each angle inside the triangle is equal to 60. So that would be an example of a regular polygon as well. Yeah?
I think a convex is where only the angles, sides.
I don't know. Where are you heading with it?
He's going for it.
Sides are all the same.
No, convex or concave doesn't have anything to do with congruency necessarily. Nick?
For a concave, it's two lines that head in on itself.
Okay, I'm gonna kind of reword what you said here, but yeah, we'll start with a convex polygon as we go in order here. So a convex polygon is a polygon where an extended side does not pass through the polygon. Okay. It's a polygon where an extended side does not pass through the polygon. An example of that, a polygon where an extended side does not pass through the polygon, would be like the home plate pentagon that we talked about before, right? If I extended any one of those sides, it's not going to pass through the polygon. There's the bottom, there's the left extended, top left, top right, right side, right? If I extended any of those sides, it's not going to pass through the polygon, okay? Your stop sign would be another example of that, right? Just continue drawing, it's not going to pass through the polygon. Concave, then, would be the opposite. A concave polygon is a polygon where an extended side passes through the polygon. A polygon where an extended side does indeed pass through the polygon. Making another pentagon. Okay, we made a home plate for the first one. So making another pentagon here. 1, 2, 3, 4, 5. This one will be convex because if I extended either of these top diagonal sides, it passes through. Okay. So where Nick was saying where like the angle kind of goes in on itself, I think that's what he meant here, right? Right. This angle kind of goes in towards the polygon versus the pentagon, the home plate one, where they kind of stay outward there. But yeah, so this would be a concave polygon, and then convex polygon, you extend, it stays on the outside. Okay. Do you see the difference? Is it clear? Good. Thumbs up. Okay. So going down, here, a nifty tidbit. Look at this. A way to remember the difference between convex and concave is that you can go inside a cave, just like the segments extend inside a concave polygon. That's classic Schultz thinking right there. Okay, put that on a help sheet. Big brain indeed. Draw and label each of the following. A regular octagon. Describe for me what a regular, normally I'd have you come up here and do this, but of course, hashtag COVID. So describe for me what a regular octagon, what characteristics is that going to have? Regular octagon. What does regular mean? Tell me about an octagon. What do we get? Let's get some new. McKenna.
All the angles and sides will be congruent, and it will pass through the top.
Exactly. So your stop sign, right? 8 sides. And especially with a pen that's not very calibrated very well, does that look like all sides are congruent? No. So how can I label it so that each side is congruent? You put the tick marks in, right? Now I'm telling you, okay, this is a freehand drawing. Just get over it. All sides are indeed congruent. And what's the marking for congruent angles? Who remembers from PO7?
Like a little arc.
The arc, yeah. Okay, put the arc in each angle there, and that tells you that they are all congruent. Okay. Yes, Luke.
I was wondering if I could help with the next one.
Sure. Convex Pentagon. Tell me what that's going to look like.
So there's probably going to be 2 angles where they're pointing either one is pointing more upward.
Okay.
So like you take like 6 sides. And you take
How many sides?
6 of the sides. You take 2 and you,
For a pentagon.
oh, sorry, no. You take 3 sides and you have 2 pointing up, correct? Or am I wrong?
Well, pentagon has 5 sides.
Yeah.
Okay. So when you said 3 sides, what do you mean?
So like you take 3 sides and you complete them normally how you would.
So kind of like our home plate?
Yeah, and you draw it.
Yeah. Okay. That would be a convex pentagon, our same example we used up above in the definition. Okay. Convex concave doesn't really have anything to do with congruency, so we don't have to mark that here. It was just with that first one there. A concave decagon. Concave decagon. Yeah.
The star.
Dumonso.
The star.
The star would be a. You're going to make me draw that again. I did so well the first time. I don't know if I can duplicate it. 1, 2, 3, 4, 5, 6. Oh, man. My first one was better. But yes, that would be a concave decagon. If you were to extend the segment, it would pass through the figure. That's what gives that concavity, concaveness. And then decagon, 10 sides. A regular convex hexagon, that's our honeycomb. 1, 2, 3, 4, 5, 6. That looks horrible, actually. I'm going to redraw. Oh, man. Yeah, whoever said, what is that? I agree with you. That was not good. Ever tell you I got a U in art? Yeah, when I was in 3rd grade, I got a U in art. U stood for unsatisfactory. In art. Unsatisfactory. That's why I do not teach art.
And that's not how you are.
That's exactly right. Well played. But regular convex hexagon, 6 sides. Those sides, if extended, would not pass through the hexagon. And the regularity of it means it has those congruent sides and congruent angles. Down below here, it says classify each polygon by its number of sides and whether it is concave, convex, or regular. Take 2 minutes and just answer these 3 yourself. We'll come back and take answers, but give you a chance to kind of practice this. Back at it. What'd you get for the first one? Who'd like to raise their hand and share their classification? Convex, concave, regular, and number of sides. Someone we haven't heard from yet today, perhaps.
Oh, you've heard a lot.
Heard Kylie.
Hexagon and it's a concave.
Did you say hepta or hexa? Heptagon, concave. Concave heptagon. It's concave because if you extended these sides, it would pass through, right? And then it's got 7 sides, making it a heptagon. Next one, who'd like to... You're also eager to share your treat ideas for the Mario Maker, but not so eager to share your side classifications. Luke!
Regular pentagon?
A regular pentagon. We see it's got 5 sides. It's got those angle markings there. Even though it doesn't have the side markings, if it's got congruent angles, what makes those congruent angles? The sides do, right? The lengths of the sides kind of determine the measure of the angle. We'll talk more about that in a little bit. And so you don't necessarily need them here. Folks, come back. Brady? Convex Pentagon. Convex, looks like convex. Convex Pentagon. Any questions, comments, concerns, complaints, compliments, congratulations, or criticisms on that?
Okay, play me if you give us homework.
You are going to get homework on this one. Luke.
Yeah. With the 100 gon, how would you be able to, like, if you were to give us like a 100 gon or like a 22 gon?
Yeah.
How would you be able to tell if that's concave or convex? Because you have to have different weird angles.
I mean, you could probably tell pretty easily. Yeah, you can probably tell pretty easily, actually. We'll leave it at that. Okay, your homework for this page is on, let's go 45. 45. Page 45. I would like you to do numbers. Ooh, maybe not. Actually, on page there's some algebra stuff in here that we haven't gotten to yet. That's why I'm hesitant on assigning. You haven't learned factoring yet. And that's what's required on some of this stuff. On page 47, we'll call an audible. Page 47. I'm like Kirk Cousins. I read the defense, called an audible. Yeah. Number 40. That's it. Page 47, number 40. It's a chart, and everyone loves to fill out a good chart. And then you have questions A, B, and C afterwards. So it's a bit of an extended response, but it is a chart. Yes, Christopher. Shh, girls. Yes, this is in your textbook. Yep. Max. Okay, that's how you math.